Give your biggest round of applause, everybody. Puru Vijay!
Thank you. Thank you. Hello. How is everyone feeling after that really heavy lunch? Nice. Nice. Should we do some exercise or are you all pumped up enough? Pumped up enough. Yeah, good, good. Okay, all right. I'll begin now. So, hey folks, today I'm going to talk about harnessing the titans of animation and performance in React. Now, what the hell does that even mean? You'd have to ask ChatGPT because that only came up with this title. The human version here would be simply how to use Svelte in React. Now, why would you even want to do such a thing? Isn't React enough? Short answer, yes. But long answer, it kind of depends. This is what we are going to find out in the next few minutes. First of all, I would like to introduce myself. My name is Puru. I come from Jaipur, Rajasthan, which is in the desert of India, so no camel jokes, please. I'm a full-stack developer with over 9 years in the field, NPM author in the Million Downloads Club, an open Sourceror, and an absolute performance freak, and a self-proclaimed bundle compressionista. Okay, before I move forward with this topic, I want to address the elephant in the room. This talk isn't going to be me telling you to switch to Svelte or React ain't good or any of that stuff. Just no, not at all. React is great and it is here to stay. Yes, who? But like any strong piece of technology, it can't do everything, which is where alternative frameworks like Svelte can truly shine. This ain't gonna be a React versus Svelte. It will be a React and Svelte. How they both can improve each other, not just from a competition standpoint, but actually within your app. How they complement each other while being in the same code base. I could just tell you why you would even want to use something like this and then show you how to do it, but no, that would be too easy. Instead, I would like to take you through the journey of what it takes to make that happen and collapse it all into a very nice, simple API. How does a React app work? You make a new component, drop it in the app.tsx, and you're good to go. React automatically takes all the state within and deals with the JSX accordingly. We mount it to the DOM with createRoot.render function. Similarly, Svelte also has a mount function which takes the component, attaches it to a DOM element. This is also similar to React's .render function in the sense that it only needs to be passed the one component containing your entire app. Now, let's look at what all we need to do to have Svelte work inside React. We just need a component, being the counter here. Second is a DOM element to attach the component to. And lastly, the mount function from Svelte. This is the code we will start with. Let's go through it. We import the counter.svelte component and the mount function. Then we have a React component and the ref to hold the only JSX element within this component. And then we initialize a use effect and run Svelte component initialization code in it. Why the empty array at the end? Because we want to mount our Svelte component only once and only once throughout the lifetime. And in the end, we have a div element with a reference and stuff on it. And let's not forget, what gets mounted also has to be unmounted. So let's destroy this when the React component also gets destroyed. That's it? No, not yet. We still have a few things to worry about. Namely, props and reactivity. The code I showed does not allow for props, and we should be watching them for any changes and notifying the Svelte component. And just like browsers don't understand JSX and it has to be compiled down, we got to compile .svelte down to JavaScript as well. And lastly, just automate the damn thing. As you can see, we are not passing props anywhere in this component. Let's fix that. Whatever props we receive through the React component, we pass it to the second parameter of the mount function. Then one problem that arises is the prop syntax difference between Svelte and React, which isn't much, thankfully. So we can write a simple normalized props function to convert the prop names from React format to the Svelte one. This is how it looks. Now we directly pass the normalized props to the Svelte component, but of course, we are still missing something important. These props are not reactive at all. I can do this and it will work flawlessly. But this just will not work. Count will update, but the component won't change because it simply isn't watching the props from React and notifying the Svelte component. Let's change that. Coming back to the code, we need to be able to react to the props parameter. And the best way to do that in React is a use effect. Here we are watching props, and once it changes, we wish to let the Svelte component instance know that, hey, these props change, you should also change. How do we do that? You would expect that we would store the instance in a variable and then call a .update method on it or something. You wouldn't be too far off, as that's how Svelte 4 used to work, with a $set function instead. However, Svelte 5 has changed. It's about to come out in just a few days, as if I'm not wrong. We will write this code in Svelte 5 component style only. Let's think this through from the very first principles. This is how we initialize the component. For clarity, I have moved process props out to its own variable. You will see very soon why. Now we will use $state on the process props. Sorry, just before I move on, is anyone bothered by the snake case? Anyone? Okay, it's a minority, then I'm safe. Let's go. So this is what happens. Get it? We wrapped process props in a $state. What is $state? $state is what you would call a rune. Runes are primitive reactivity blocks of Svelte 5, and $state specifically is used to declare a state variable, just like a use state in React. On the left side, you have a simple React code, and on the right is the Svelte version. The reason you can directly assign to text in the Svelte version is because Svelte is a compiler. It does call a set state function, but you never ever have to see that. It all happens in the compiled version. I don't want to complicate this too much, but for those who are curious, this is the generated compiled code. $state becomes $.state, which is like use state, and text equal to expensive petroleum becomes $.set text, expensive petroleum, which is equivalent to set state only. By the way, the code in the previous slide is inspired from this fantastic meme. I'm a huge Harry Potter fan, by the way. Any Potterheads here? Yo, this is my fam right here. Absolutely. So, coming back to the code and how to update the props, we wrap process props in a $state to make it reactive. So by effect, we are actually passing the reactive properties to the mount function. Hence, it will react to any prop changes. Next step is actually changing the props with object.assign. Direct equal wouldn't work here because Svelte is extremely fine-grained. The deep level assignments will not be caught here. So here, that's why we use object.assign. So here is the full code with the reactive properties. Thanks to how the Svelte compiler works, we can directly assign to the reactive process props, and it will work. Notice we have the process props updating in a use layout effect rather than a use effect. This is because use layout effect runs before use effect, and in the very beginning, our reactive props are null. We don't want to pass a reactive null to the Svelte component props. This is why, and this is why. So, and then the use effect runs, which will mount the component to the DOM with a properly parsed and normalized reactive props, not a reactive null, thankfully. So, pay attention, pay attention. Remember how I said a minute ago, thanks to how the Svelte compiler works. You may be thinking, but this is React code, Puru. We aren't going to run the Svelte compiler on a React component, right? Right? Well, this is exactly what we are going to do. We are going to pass this React component through the Svelte compiler. It will transform the Svelte bits out, and then the React DOM is none the wiser. I'm probably committing a JavaScript war crime doing this, but it's too late now. Let's see this through. Next, since we are not in a Svelte project, we need a little elbow grease to transform the Svelte files into JavaScript before we can use them in our project. Here, for simplicity's sake, I'm going to assume we are working in a Vite app, which means it's either a create Vite app for React or Remix. We are going to install the official Vite plugin Svelte. And assuming this is how our Vite config looks, we are going to add the Vite plugin Svelte to it as well. That, to be honest, that doesn't look that weird as you would think, like React and Svelte next to each other. But anyways, moving on. This is all we need. Now our code will work. So now we have reached a fully working solution to get Svelte work running in React. It accepts props and they are reactive, and the Svelte files are properly transformed down. Good enough. And these are the 3 files we changed to make it happen. But now, what if we introduce a new component into the mix? A word counter. To make it work, we just copied over all our code from counter in react.tsx, just change the imports, and we are good to go. But now we have a total of 5 changes instead of the ideal 2 we should have had. These are all the files in the project now. If you can see, like, the main business logic is just on the very first column, counter.svelte and word counter. Everything else is just boilerplate, and that's a bigger portion of it. Sorry. So for every Svelte file we add, we have to add an extra wrapper for it. So cumbersome. It is a 2n+1 progression. For every file you add, you have to add another one as its wrapper. It is quite cumbersome, I would say. Of course, we can alleviate this a little bit by converting the bridge code into a reusable function. So the code above just turns into a function which returns a component. This is an abstract function which takes in the Svelte component and spits out the React component. And the usage is quite simple. Just import the function, pass it the Svelte component, and use the output React component as is. Much easier. This is a much simpler and decluttered file structure than before. And we can also say that our file system's complexity sequence is just n+2 now, which means you have to touch these 2 constant files, React wrapper.ts and the Vite config. Afterwards, for every Svelte file you make, that's it. That's the only file you need to make. There's no more wrapper. Now that our code is much simpler and scalable, it would be really nice to not have to convert the component myself. I can very easily forget to run the component through the React wrapper function and use it directly, like this. This is going to error out and not work because you just can't take a Svelte component and drop it in React. It just doesn't work as is. So the previous solution is the best we can do, right? Well, nope. We can make this even easier. Let's go back to this pipe dream. This code doesn't work, but that doesn't mean we can't make it work. With a tiny modification, this pattern becomes very much possible. And that is adding the $React parameter at the end. Feels quite clean and tells the intent as well. Now, how do we do this? With the Vite plugin, of course. Vite plugin allows us to intercept the code before it is served to the browser, process it, transform it all during build time, and output the same code that we discussed before, all without the user ever having to see any of that stuff. Just hide all the complexity away. Let's talk about how to write one. First one is the name of the plugin, which should be unique. Afterwards, we have the resolve ID method. It allows us to intercept the imports and rewrite them. In our case, we are going to rewrite the $React suffix imports to our own .neosvelte-react imports. Why? Because query parameters themselves don't make that import exclusive to our Vite plugin. If you go to a web browser and you put a query parameter at the end, it's not necessary that your view will change. It might, but it may not. It has to be, so here it has to be rewritten to a format that no other plugin can understand to avoid any race conditions. Afterwards, we have the load function, and we use it to intercept the, and then we use it to intercept the .neosvelte-react file format and return some content for it. Think of it as providing a virtual file to the browser to work with. Let's flesh this out a little bit more. Motion alert. So what just happened? We added a new property to the plugin, enforce pre. This tells our Vite plugin to run before any other plugin. We do this so the official Vite plugin Svelte does not reach our .svelte?react import before we do. Everything will fall apart if that happens. Then we got these 2 lines within resolve ID. We are resolving the true absolute paths of the Svelte file. So if it is something like ./app.svelte, we will resolve it to /user, /username, /project, /blah, blah, blah, whatever that is. And then we return it as the ID, but with .neosvelte-react appended to it, which marks this file as nonsensical to Vite and any other plugins there are. So now our plugin owns this import. A way to visualize this step would be this. In the end, we have the .neoswell-react appended. We just sees it as a regular file. It tries to go through the file system. It doesn't find anything, so it ignores it. So we are safe from any race condition here. Let's come back to our original Vite plugin, sorry. Let's focus on the load function. Load is also run for every single import that Vite encounters, but instead of overwriting the ID of the module, its responsibility is to provide content for the module ID it just received. So now we have our check to make sure the ID ends with a special format. And if it does, provide the code. This is slightly hard to read, so I will put this in the next slide in syntax highlighting. Remember the old React wrapper function we built before, to which you pass the component and it spits out a working React component? Before we were importing it from /wrapper.ts, but of course that won't work now. Hence we have moved it to a virtual module. Next up, we are importing the raw Svelte component from its original paths. This is what Vite plugin Svelte will work on. And lastly, we are just exporting the React component that comes out of the React wrapper. To use a virtual module, we will install the excellent Vite plugin virtual package and then specify the virtual name along with the content to go into it. We just copy paste the content of React wrapper here, so it's omitted for brevity. And if you look at the file name is react.svelte.js. It is that way because Svelte compiler doesn't process .jsx file. Why does it not do that? Because why would this team even think that they would have to transform JSX file one day, the Svelte team? Forgive me, Rich and Simon, the maintainers. So once all this is done, let's package it all up real nice and good and put a bow on it. We have got 3 different plugins now. Svelte to React, Virtual, Vite plugin Svelte. We just have to put all of these together into a really nice API. Luckily, Vite provides this really nice way of composing plugins. A plugin itself can just be an array of multiple Vite plugins. So we just put all these together, slap the name NeoSvelte on it because why not? And then we just put it in our Vite config file as a one-liner and boom, it works. No need to make your own wrapper files or any code gen that could litter your file structure. It just works. Let's review this new setup. Install the NeoSvelte plugin, add it to your Vite config, then author your Svelte files normally, and then directly use these Svelte files within your React project by just appending React at the end. So thanks to this NeoSvelte plugin, I am down from this convoluted structure to just this. It's almost we are in a Svelte project. So coming back to the question for like the 3rd or 4th time, I've lost account of it. Why do we do this? For performance and animation. Let me elaborate on that. I haven't told you all the best part of Svelte, and that is animations and transitions. As you can see on the screen, this is all the stuff that Svelte provides for animations and transitions. You have got the Spring class, you have tweened, and then you have a gajillion functions for easing. You can just time these animations however you want. It's very, very good. Look at this demo. The ball on the top is running with the linear easing, whereas the bottom is running with cubic. The second one looks more natural, a little bit like a pendulum. This is all being done in Svelte, and the code to do is just this. Just this little code is doing all of that. There are no dependencies involved here. Svelte is doing all the heavy lifting. And just a fun fact, when you compile this down to plain Java set, minify it, it doesn't even reach 2 kilobytes. Whereas with popular React libraries, it would be anywhere from 7 times to 20x bigger, depends on which one you use. Oh, and just an aside, this demo is not a GIF or a video. It is actually running here in the browser right now. In fact, I can unleash some confetti right now. Just where it is? Oh, it worked. So it is live. It's not a video. I'm not fooling you. The significance of this is that I am using slidef.js for my slides, and it uses Vue.js. But the ops demo, this is written in Svelte. Hence, the hint is I have NeoSvelte working in Vue as well. Svelte can work anywhere. Anyways, thank you. Anyways, coming back to this question for like the millionth time now, I can sum up my answer as this. Using Svelte in React is actually equivalent to using Rust in JavaScript. If I had said this statement 10 years back, it wouldn't make any sense. However, then we got something that changed the entire game. WebAssembly. WebAssembly allows you to run Rust in JS to run some really intensive code extremely fast, which JS can't do. And we have seen some really great stuff with it. Figma is probably the best example of WebAssembly. And wouldn't it be nice to have something like that for frameworks as well? Use your preferred frameworks. Use React, use Angular, whichever one you want. And for the performance-hungry bits or animation, just drop in Svelte and be done with it. You don't have to buy into one framework. Just include them whenever you want. NeoSvelte is a WebAssembly of frameworks. So, moving on, let's look at a more interesting example now. Who all use a MacBook here? That's like 50% of the crowd. Really, really impressive. So, you know of the magnification effect when hovering over the dock? I believe I can show it. Yeah, this thing. It is an absolutely fantastic animation detail from Apple. I love it so much that I created an entire website about it. It's called macosweb.app. Has anyone ever come across the site? I mean, I made it. So. Oh, just a few people. OK. So it features this beautiful dock with the animation on it. You can try it out yourself by typing out that URL. Please use a desktop. It sucks on mobile. The site was created originally in React with Framer Motion and then slowly optimized until I realized that, hey, it will be the smallest in Svelte. So 200 kilobytes JavaScript to just 30 in Svelte. Which gives me, and this gives me something unique, by the way. I have a React version of this doc, and I have a Svelte version as well. We can directly compare both of them, but for the Svelte version, we will use NeoSvelte. So we will import the doc within our React app with NeoSvelte, and then we'll see the size difference. So here is the code for the React version. We are a little bit low on time, so I won't go into it too much. This is the doc component. This is the doc item. This does all of the heavy lifting. It has the framer motion, use request animation frame, a lot of work. Now let's calculate the bundle size of the doc component. Easiest way to isolate it from anything else is using it with a dynamic import, which will give us a doc.hash.js chunk, which can be inspected on its own. Can anyone guess what the bundle size of it could be? Anyone? Sorry? 10. OK. Anyone else? 5. Anyone else? Sorry? That is way too small. So anyone else? That was a React code, by the way. This is React, Framer Motion. 60? 50? I think you are the closest one. It's a little bit under 38 kilobytes, minified plus gzipped. It does not include React or React DOM. It only has Framer Motion because this component is the only place we have Framer Motion. So it's a fair game to include it in the chunk. 38 KB may not seem too much, but considering you are building a React app, you already are loading 46 kilobytes of React libraries at a minimum, making your app 82 kilobytes minimum for this one. Real world will be much bigger. Let's do the same thing in Svelte. This is the doc component. This is the doc item of Svelte. We measure it in the exact same way, but as you can see, we have question mark React at the end. Any guesses now? Come on, just try. It's not that bad. 1 KB, that would be perfect, but no. It's 6.3 kilobyte minified plus gzip, all the way down from 37.9 to 6.3. This is a 6 times reduction. Same behavior, yet different frameworks. Now, how far can you even take this idea? To infinity and beyond. Just for funsies, we can build the reverse NeoSvelte also, which I can call Neo-React. This is a way to use React components within Svelte apps. As I speak this, I'm sure the Svelte team is preparing a lawsuit against me, but hey, I'll deal with that so you all can pass on my legacy of chaos. With the same methodology, you can build any number of combinations. I'm aware that this can be quite a controversial idea, and I for sure hope there aren't any React core team members sitting here or any other frameworks undercover cops for that fact. Is Satya here? Satya Gunsegaran? OK, I'm very safe today, thank God. And you may think that this is crazy, but this is pretty much what we do in micro frontends. Only the difference here is that instead of splitting at the app or route level, or even application actually, we are splitting at the component level. Svelte is just a very granular version of that. You can have an entire Svelte app in Svelte, or just individual components sprinkled around your app. Go figure. If you look at this, this is also just an inverted version of Astro. Astro allows you to have any number of frameworks in the same page. Pretty sure when they pitched the idea to people, people thought it was very, very crazy. I for sure thought it was absolutely bonkers. But here we are with Astro having highest developer satisfaction and interest scores in State of JS survey. This is the results of State of JS survey 2023. As you can see, Astro is #1 in result. It's right here, this thing. Tells you that there is some substance in this idea of mixing multiple frameworks together. Now, where would you want to even use this? That's the main question. Svelte excels at both animations and performance. So for landing pages, which are the most animation critical areas, Svelte's performance and easy animations, transitions could give you a really fast, snappy UX in no time at all. For huge companies with multiple teams, you can have one small team make a Svelte app and then inject it within the large React app and be done very, very quickly. This is micro frontends, sort of. And lastly, it helps you avoid re-renders. Technically, this comes under performance itself, but I just cannot stress how impactful this one is. One of my colleagues, he said that once he consulted on a React code base, and in some parts, every button click on a form was causing 100 re-renders. Just one button click, 100 re-renders. Every single button click, oh, I'm repeating, sorry. In React, renders get out of hand. And they usually are not caught unless you are explicitly looking for them. And because of how the app development lifecycle goes, performance is usually the last thing. Whereas in Svelte, you get renders only and only when something changes deeply. You have to be very explicit about this stuff, which automatically makes interactions feel faster. It is performant from day one itself. There is still some room for improvement, though. This virtual file pattern does not allow for type safety yet, which can be mitigated the best with a code-generated Svelte directory with types in it, which will be auto-updated as you modify your component. Server-side rendering. These few Svelte components will not server-side render themselves. This is a bit complex part. For Vite, it's different. For Next.js, it would be different. You need different codes for that. And lastly, a layer to share state across the different frameworks. Now, why did I not go through these in the talk? One, not enough time. And second, simply because I wish to come and speak on this topic next year also. So organizers, please take a note if you can. So with that, we have come to the end of the talk. These slides can be found at the link below, below the QR code on the screen. I'm on Twitter at the handle Puru Vijayvargia. Huge thanks to Mohammed Bagar and Brady Fractal for giving extensive review on this talk. The slides are built with Slider. The beautiful font is Stardom. The code theme is Cappuccino Latte. And the confetti is neoconfetti/view by yours truly. Thank you for coming to my talk. Have a great day, you all.